Hi everyone, it's Blockchain Bernie here with my latest episode. And this one is about my experience with the Rust programming language. And I switched to Rust with a mission critical app. And I'm going to tell you in detail what happened and what the experience was, and if I would do it again, and what would it mean for you and your apps and your, you know, career, and do you want to learn Rust or no? And that's what we're going to talk about today. If you like this content, please give it a thumbs up. I really appreciate it in advance. It's really important for the YouTube algorithm so that content like this will be available to more people. Also, subscribe to my channel and also hit the notification bell so that you won't miss any of my videos. So why did I switch to Rust? It was a mission critical app, and that app was our own crowdfunding platform, right? We were raising funds for our latest project. Latest project is Bitoku, bitoku.io. See the link in the description. And we needed to raise funds for it. We wanted to do it with crowdfunding. We did not want to do it with venture capital or business angels or anything. We wanted to do it with crowdfunding. And since the project is based on the Solana blockchain, we wanted to do the crowdfunding based on the Solana blockchain as well. So it was obvious that we wanted to use Rust to develop the back end of that app. And the back end means the smart contracts that run on the Solana chain. And, you know, it turned out to be like 2,000 lines of Rust code plus 3,000 lines or so of JavaScript for the front ends. So it has been quite an app. And I didn't know any Rust before that, right? So, and my background, I'm kind of a systems programmer, a low-level programmer, right? Like many decades ago, I started with really small computers that didn't have much, you know, RAM or much storage space or anything, right? So we needed to be really economic with space, right? And put as much into 1 byte or 10 bytes or 24 bytes as possible. And the first computer I had like 32 kilobytes of RAM, right? And that included the video RAM, right? So we were really constrained, and I'm from that background, so I did some assembly language in my early days, and then did C and C++, and you know, the whole journey there, right? But Rust then is something like, well, it's not like one of these modern high-level languages that put more and more layers of abstraction on it. And what I see these days with young programmers, they don't really understand how this all works and how, you know, things are stored in memory and how much space they take, and, you know, what might be efficient, you know, with compute units, or what might not be efficient. Many people don't really know, and they might be good programmers and they might be super helpful in projects, right? Not everyone has to understand that. I just want to give you my background. I am from that systems programming group of people, right? So with Rust is then built for me. It's built for people that want to do systems programming, that want to develop close to the hardware, right? That want to know, is this integer, is it a 16-bit integer, or is it a 32-bit integer, or a 64-bit integer, right? Is it signed or is it unsigned? And all these type of things, right? I personally love that. I love working with the computer, right? And not only, you know, writing some code that, solves the problem space. That's important also, right? And it is important to have higher and higher level programming languages, and even have artificial intelligence someday in there helping develop software faster. But, you know, programming close to the hardware has its place also. because without that, some things wouldn't just be possible, right? There's the whole chain from the problem domain down to several layers, but at some point it needs to be executed by some real hardware, just as this MacBook, for example. So yeah, and Rust is made for people like me. And since Solana is a smart contract platform on the blockchain, it needs to be performant, right? Because Solana is built as a scalable blockchain. It is the most scalable public blockchain, smart contract blockchain in the world, right? So it is using Rust internally. So the first Solana validator software that has been written by Solana Labs is written in Rust. There's a second validator being written as we speak called FireDancer, and that's being developed in C and C++, just as a second implementation. But I switched to Rust, and I thought, like, man, knowing C, C++, Pascal, assembly language from my early days, right? And then after that, having learned all those newer languages, right? Like, for example, Python and Ruby and, JavaScript and all these things, right? I thought, like, well, it should be relatively easy to learn Rust, right? Rust has quite a learning curve. I need to tell you that, right? Even if you already know systems programming and programming close to the hardware, it takes some time to learn some concepts there. And the key thing is Rust aims to be safe, right? It aims to be thread safe so that you can run things in parallel without breaking the breaking your code or breaking things there. And it's also like memory leaks, right? Where just memory has been, when you do programming close to the hardware in like C or something, you can allocate memory, you can free the memory that you've allocated before. But then if you make some mistake and you just free it, but then use it again later anyway, or things like that. And practice has shown that this is so easy to do. And on the other hand, it is so hard to prove that any given program, if it has a sufficient size, is free of these memory leak errors, right? It happens all the time, and it has catastrophic implications. And if it's just your personal PC that crashes because of that and you have to reboot it, that's one thing. But if it's on a server that does mission critical stuff for thousands or millions or hundreds of millions of users, then the consequences are catastrophic, right? So it is, or just the Solana blockchain, which is written to be scalable to billions of users, right? And think about, there is just that memory leak, and suddenly everything's down, right? Which won't happen that easily on distributed systems as it will on centralized systems, but still, that's a big problem, right? And Rust is solving that, right? It has several features in the language, mostly called borrowing, that prevent these memory leaks from happening, or any memory errors or race conditions or stuff like that from happening. And it takes some time to get used to that, right? So it's not like even if you've learned so many new programming languages and you're used to, like, oh, I can do it really fast, you can still do it fast with Rust. And most of the time these days you learn by example and you see some sample code, and if you can't move ahead, you search something on Stack Overflow or somewhere on Google, and you can do that with Rust as well, right? You can do learning by doing. So that's perfectly fine. But if you're like me and you want to have some understanding first on how everything works, be prepared to need a week or so with where you don't do anything else other than reading the Rust book and trying to figure out how all these concepts works and getting used to it, right? After you've done that, it is really fantastic, and you probably don't want to use anything other than Rust anymore, right? For me, it's always hell having to write all the front end in JavaScript and or TypeScript just because it's so ubiquitous in any browser, right? It's tough to get away from that, but it's a very different experience because there's so many, flaws in the JavaScript and TypeScript languages and in the tool sets that are out there, right? And with Rust, you don't have it, and it is strongly typed, and the compiler actually gives you so helpful messages. It is fantastic. Yeah. So it's almost like the compiler is a type of AI, a type of artificial intelligence that is trying to figure out what you want to achieve. And the Rust compiler is really nice in talking to you, right? Not like, oh, I'm the compiler, I couldn't do this because blah, 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 and talking about itself, the compiler, right? As it's happening so often. But these guys that built the Rust compiler, they were thinking about you as the programmer, right? And they're giving you messages like, hey, you wanted to achieve this, but here you did that, and here you did that, and that's kind of a contradiction. And here's the two options you can resolve this conflict, right? And that's like, wow, it's almost like having your personal assistant for programming there, right? It is fantastic. So it has been, a great experience for me to use Rust, and I want to use it wherever I can. Sometimes, of course, I can't. It is super performant, right? So if I want to build a quick command line tool to do me some, help me with XYZ, I'm doing that in Rust now all the time, and yeah, it's my new Python, right? But it's it is, for me as a system programmer, it's so much better than Python, and it's so much more performant and everything. So I absolutely love it. If you like this video, please give it a like. Don't forget that, because it's important for the YouTube algorithm, please. And with Rust, you know, it was just one thing for my app, right? The other thing was it was a Solana app, right? And the Solana development experience was something else, right? Solana puts so much stress on performance, right? That you'd have to declare in each and every Solana instruction which accounts it will read to and write to, and that has to be on the highest level possible, on the level of a transaction. So within a transaction, there can be several instructions that call each other and stuff like that. So it is a little bit of not all too ergonomic, I would say, in Solana to always have to declare all these accounts and, kind of thread them through all these different layers and always carry them with you, and not being free as a programmer to just at some level of the call chain, right? You want to encapsulate, right? But you really can't encapsulate in Solana in some instances, because from the top level you will need to make sure with all the nested things that are in there, even if they're encapsulated in what's called a Rust crate, right, which is like a library or something. Even if it's encapsulated there, you would have to pass in all these accounts all the way from the front end to the lowest level down there. And that is, to me, the most annoying thing with Solana, with the Solana development experience. I 100% recognize that this is necessary for their runtime environment to be super fast and to be parallelized. And that is so exciting that Solana can do that. And that's why it's orders of magnitude faster and more scalable than any other blockchain that I've seen. But it has implications for the developer experience. I just want to say that. So that came with Rust for us. But with the actual Rust language, I'm a fan, right? I'm really a fanboy. So try it out. Get started with Rust today. Thank you so much for watching, and catch you later. Bye.